Recording this. Okay. We've defined what a radical was. We have simplified that radical. We have actually multiplied radicals together and then simplified them. We go into the addition and subtraction of radicals, and then we're going to do the division of radicals, and then normally you would move into equations involving radicals. And then after that, in order to do equations, then comes the applications. So at which point we're now just going to add and subtract them. If you're just dealing with numbers, it's easy. I could do it with my calculator and get it to 8 decimal places. So at this point, we're just going to play the game of working with exact answers, which means it includes radicals. But adding and subtracting, if you can add and subtract like terms, you can add and subtract radicals. If I know what 2x plus 3x is, 2x plus 3x is 5x. It would also be the case as 2 square roots of 2 plus 3 square roots of 2. The question is, how many square roots of 2 do you have? You have 5 square roots of 2. So it says those square root of 2 were an x. So if you combine like terms, you can add and subtract radicals. Issue is they have to be like terms. So in other words, I can circle everything but the number, and what I've circled would have to be the same, just like I did when I was dealing with variables, and I would be counting how many circles I have. Subtraction would operate on the same level, and this says if I had 5x minus 2x, it's 3x. Well, if I have 5 square roots of x minus 2 square roots of x, essentially circle everything but the coefficient or the number. If what I've circled the same, I can count how many circles I have. It's going to be 5 circles minus 2 circles, which is 3 circles, which happens to be 3 square roots of x.
Right.
But they have to be like radicals. They have to be identical, because you're counting how many you have. Now, if I take a look at this problem, I have 1 square roots of 10 plus 1 square roots of 10 is going to give me what? 1 square roots of 10 plus 1 square roots of 10 is 2 square roots of 10. Yeah. And 1 square root of 7 minus 5 square roots of 7 is minus 4 square roots of 7. Now I notice that these are all cube roots of 11. So if I circle everything but the coefficient or the number that's in front, that says I have 16 circles minus 9 circles minus 2 circles. So 16 minus 9 is 7. 7 minus 2 is 5 circles, but in this case the circle is the cube root of 11. Now here I have a problem. And you're going to say, well, why do I have a problem? Well, if I take a look at the radicals, are they the same? No. Now, what I want you to think about, these are square roots. That means that what I'm going to have to do is I'm going to have to break each term down and simplify each radical. Now, here's the key. Can the square root of 6 be simplified? No. Can 54 be written as 6 times a perfect square? 6 times what? 6 times 9, yeah. And what about 24? 6 times 4. So the key is that I can write 24 as 6 times a perfect square, 54 as 6 times a perfect square, and this guy is, all by his lonesome, he is 1 already simplified. So each one gets broken down. So this becomes the square root of, remember, 4 and then the leftover plus 2 times the square root of 9 and then the leftover minus 1 square roots of 6. The square root of 4 is 2, square roots of 6, plus 2 times the square root of 9 is 3 square roots of 6 minus 1 square roots of 6. So this is 2 square roots of 6 plus 2 times 3 is 6 square roots of 6 minus 1 square roots of 6. So 2 square roots of 6 plus 6 square roots of 6 minus 1 square roots of 6 is 7 square roots of 6. So it's like 2 circles plus 6 circles minus 1 circle is 7 circles, and it happens to be the square root of 6. You can't play around with it. You're just going to have to go in there and do it very, very carefully, one term at a time. Now this one is of no help because why? 24 and 81, I'm dealing with cube roots now. I need to see if I can have what's left under the radical to be the same. And if I look at 24, what is the largest cube that's in 24? Because that's the easy part. 8. So that says that this would be the cube root of 8 times 3 plus 9. Now, I need to I'm going to have a 3 as a leftover. If I divide 3 into 81, what do I get? (27). Is 27 a cube? Yeah. So that says this guy's going to be 27 with a leftover of 3. So they're both going to have leftovers of 3. Once I break one down, I'll use it to break the other down. So this then becomes 2 cube roots of 3 plus 9 times 3 cube roots of 3. Which is 2 cube roots of 3 plus 27 cube roots of 3. 2 cube roots of 3 plus 27 cube roots of 3 is 27 plus 2 is 29 cube roots of 3. These are very detailed problems. That means they're not much fun. They're more drudgery. And they're the ones where you can go in there and kind of fall over yourself quite easily if you're not careful. That's why you don't want to go in there and try to just quickly work it through. Work it very carefully through. One step at a time. I'm back to square roots. I'm going from square roots to cube roots back to square roots. And I need the square in, and so this is going to be 10. And I'm going to take this guy, minus 4, and then this guy. The square in 8 is 4 with 2 left over. The square in x cubed is x squared with 1 left over. The square in 18 is 9 with 2 left over. The square in x cubed is x squared with 1 left over. Notice what the leftover in each case is going to be 2x.
Thank you.
So this says it's 10 square root of 4 times, that's what this is. When it's right up against it, it's a times, 2x square root of 2x minus 4, again, that's a times, 3x square root of 2x. So this is 20x square root of 2x minus 12x square root of 2x. Now this is where you're going to have to be very careful. And you're going to say, well, why is that? Well, because if I notice everything but the number includes a variable. So I'm going to circle everything but the number. Is what I've circled the same? Yeah, it's x square roots of 2x. Like if I had an x squared square roots of 2x and an x square roots of 2x, I couldn't combine them. So that says I have 20 circles minus 12 circles. How many circles do I have? 8 circles, and what's in the circle is x square roots of 2x. By the way, when I'm by myself, I work these problems just as carefully as I'm working them for you here. Why? Because it's so easy to make an error. It just is. The unfun part. I think this is probably the unfun part of this section. Always has to be an unfun part. And I think this is it. Okay, let's see what we got here. Square roots, yay! Square roots, so minus 7y, and I'm going to take the square root, break it into 2 pieces, plus 4 times square root, break it into 2 pieces. Well, 16 is a square. Y. And y cubed, that's a y squared and a y. So I'm going to have a negative 7y times square root of 16 is 4, left over is y, plus 4 times square root of y squared is y, left over is y. 4y times 4, or 7y times 4 is minus 28y, square root of y, plus 4y, square root of y. Again, what I need to do is take a look at, circle everything but the number. Is what I've circled the same? Yeah, I mean I can count them. So I have minus 28 plus 4 is negative 24. And what's in the circle is y, square roots of y.
So every time, like where it's 16 is a squared and y squared, you just want to take it out of there?
Yep. What I'm always looking for is, one thing for sure, is the leftovers the same? Yeah. Is the leftovers the same? And that's going to help, essentially, also help you break it down. Like I said, this particular set of material is really detailed. It just is. Non-fun.